Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss about first come first serve scheduling algorithm with an example. In the last few videos, I have discussed what is a scheduling algorithm, what are the objectives of a scheduling algorithm, how the scheduling algorithms are broadly classified into preemptive and non-preemptive. Then I have discussed about arrival time, burst time, completion time, turnaround time, waiting time and response time. I hope you have watched those lectures. If you did not watch them or if you don't know those concepts, I request you to go back and watch those videos and come back to this video. In this video, I want to discuss about first come first serve scheduling algorithm with an example. So I request everyone to watch the complete video for better understanding. The first come first serve mechanism comes in the category called non-preemptive scheduling algorithm. Let me give an overview about the preemptive scheduling algorithm and non-preemptive scheduling algorithm. Then I will discuss the first come first serve mechanism with this example. Now, when we discussed about the process state diagram, we have discussed 7 states. Out of the 7 states, we have the ready and running state. Okay, now look at here, we have the arrival time. So what is meant by arrival time is that at what time the process has been arrived in there in the ready queue. Is it clear? Now once the process is there in the ready queue, the short-term scheduler or any CPU scheduling mechanism, based on what CPU scheduling mechanism we are keeping. Suppose let's take that P1 and P3 process has been there in the ready queue. Suppose if you are using the first come first serve mechanism, the process which has been arrived first in the ready queue will be dispatched to the running state. Okay, now let's take that process P1 has been arrived first and it has been currently there in the running state. Now we have to look at what the scheduling algorithm, whether it is a preemptive or non-preemptive. If it is a preemptive, then process will be run for a particular time quantum. Will in round robin mechanism we will use the word called time quantum because it is a preemptive mechanism. Suppose let's take the time quantum is 2 units. This process needs 8 units to complete its task, but time quantum is only 2 units of time. So the process P1 which is there in the running state will be executed only 2 units of time out of the 8 units. So its remaining time is 6 units. It will be executed only for 2 units and will be shifted to the ready state. Once the time quantum is been expired or a high priority process has been arrived. Let's take that we have P1 process which is currently running. Let's take that during that time a process which is P4 which has the high priority as compared to the P1, then this will be shifted, the process P1 will be shifted from running state to the ready state and processor P4 will be shifted to the running state and it will perform its task. Okay, so even the time quantum is completed or high priority one comes, then the process which is currently running in the running state will be shifted to the ready state in the preemptive scheduling algorithms. But when it comes to the non-preemptive scheduling algorithm, once the process has been shifted from ready state to the running state, let's take that process P4. It has arrived at 0 units of time. Okay, it is there in the ready queue. Now it has been shifted to the running state. Let's assume that it needs 3 units of time to complete its task. So it will be given 3 units of time unless until this process P4 needs a IO request. Let's assume that none of this process have IO bound time, meaning is that it does not need any IO operations. Then it will be given 3 units of time. Once it is completed, it will be shifted to the terminated state. Okay, I hope you are able to understand. Is it clear? So in a non-preemptive scheduling algorithm, once the process has been shifted to the running state, it will be completed and it will be shifted to the terminated state. Is it clear? So now let me discuss about the first come first serve mechanism. Okay, to discuss this concept, let me draw a Gantt chart. Okay, once you completed drawing the Gantt chart, then half of the work has been completed. Okay. Now, what is the meaning of the arrival time and what is the meaning of the burst time? All these concepts I will discuss for you. The arrival time suggests that at what time the process has been arrived to the ready state. Now look at here, the process P1 has been arrived at 2 units of time, process P2 has been arrived at 5 units of time, process P3 has arrived at 1 unit of time, process P4 has been arrived at 0 units of time, and process P5 has been arrived at 4 units of time. So let's assume that we have a ready state. In the ready state, we have the ready queue. At 0 units of time, only process P4 has been arrived. So in ready queue, only process P4 is there. If only one process is there, in first come first serve mechanism, the process which has been arrived first will be shifted to the running state first. So the process P4 will be shifted to the running state. Okay, so it will be given 3 units of time, okay, and will be complete its task. Now during this 3 units of time, look at what are the process has been arrived. The process P3 has been arrived at 1 unit of time. Then process P1 has been arrived at 2 units of time, and process P1, P3. P3, P2 has P1 has been arrived. Now which one has arrived first among P3 and P1? P3 has been arrived at 1 unit of time. So this has been arrived first. The first come first serve. So P3 will be shifted to the running state from the ready state. And it needs how much amount of time? 8 units of time to complete its task. So from 3 to 11, the processor P1 will execute, processor P3, the processor P3 has been arrived first, has been shifted to the running state from 3 to 11 because it needs 8 units of burst time, so it will complete its task. Now, during that time, look at here, already processor P1 is waiting here, then P5 has been arrived, then P2 has been arrived. So now which one has arrived first? P1 has been arrived first. So P1 will be shifted from ready state to the running state. Okay, now P1, how many units of time it is required? 6 units of time. So it will complete its task at 17 unit of time. Okay, once P1 is completed, right now P5 and P2 are waiting. Okay, so which has arrived first? P5 has been arrived first because at 4 units of time it has arrived. So it will be shifted to the running state from the ready state. Okay, processor P5. Now, how many units of time it requires? 4 units of time. It started at 17 units of time. It will complete its task at 21 units of time. Now, P2 processor is waiting in the ready state, and once the P5 is completed, P2 will be shifted to the running state. So P2 has came, and how many units of time it requires? 3 units of time. At 24 units of time, all the process has been completed its task. Now we will discuss about completion time also. I forgot to write it. Let me write it here for you. This is the completion time. Now look at the each process. Process P1, when it has completed its task at 17 units of time, and process P2 at 24 units of time, process P3 at 11 units of time, process P4 when it has completed at 3 units of time. Okay, process P5 when it has completed 21 units of time. Is it clear? So when the process has been completed, that one we'll call it as a completion time. Now turnaround time is nothing but completion time minus arrival time. When it has completed, when it has came. Is it clear? Are you able to understand it or not? Now when it has completed at 17 units of time, what is the arrival time? 2 units of time. So 17 minus 2 is 15. 24 minus 5 is 19, 11 minus 1 is 10, 3 minus 0 is 3, 21 minus 4 is 17. Is it clear? Are you able to understand? Now we will compute the waiting time of each processor, how much time the processor has been waited, which is nothing but waiting time is equal to turnaround time minus burst time, whereas turnaround time is equal to completion time minus arrival time. So waiting time is equal to turnaround time minus burst time. Turnaround time is 15, burst time is 6, 15 minus 6 is 9, 19 minus 3 is 16, 10 minus 8 is 2, 3 minus 3 is 0, 17 minus 4 is 13. Now we will compute the response time. Okay, the response time of a non-preemptive scheduling algorithms will be equal to its waiting time only. But however, I will complete the computing the response time and I will show you that it is equal to waiting time. The response time is nothing but when the processor has been first reached to the running state. Look at the processor P4 when it has reached to the running state at 0 units of time. Similarly, processor P3 when it has reached to the CPU running state 3, P1 11. Now look at the response time of the processor P1 when it has first arrived to the running state at 11 units of time, and look at the arrival time. So response time is nothing but when it has first entered into the running state minus arrival time, so which is nothing but 11 minus 2, which is 9. Look at the processor P2. Processor P2 has arrived to the running state at 21 units of time, but when it has arrived to the ready state, 21 minus 5, which is 16. Similarly, processor P3 it has arrived to the running state at 3 units of time, but it has arrived to the ready state at 1 unit of time. So 3 minus 1 is 2. Okay, look at processor P4. 0 minus 0 is 0. Processor P5, 17 minus 4 is 13. Now look at the waiting time and response time of each processor. It is 9, 9, 16, 16, 2, 2, 0, 0, 13, 13. Already I have discussed that for a non-preemptive scheduling algorithms, the waiting time is equal to response time. Okay, is it clear for you? Now in exams, they will ask you to compute the average turnaround time and average waiting time. This is the two parameters usually they will ask you. The average turnaround time is equal to turnaround time of each process. Compute the sum of the turnaround time of each processor and divide by the number of processes. So what is the turnaround time of the processor P1 is 15 plus 19 plus 10 plus 3 plus 17 by number of processor 5. So you can compute it. 15 plus 19 is 34, 34 plus 10 is 44, 44 plus 20 is 64. Is it clear? Because 17 plus 3 is 20, so 44 plus 20 is 64, 64 by 5 you can compute it. Is it clear? Are you able to understand? Similarly, if they ask you to compute the average waiting time, then you can compute like this. The waiting time of each processor, you compute the sum, which is nothing but 9 plus 16 plus 2 plus 0 plus 13 by number of processes, which is 5. So this is the way you can compute the average turnaround time and average waiting time. Usually in any competitive exams or any university exams, they will give you the arrival time and burst time of each processor, and they will ask you turnaround time, average waiting time for a particular scheduling algorithm. Here we have discussed the scheduling algorithm is first come, first serve. Now lot of students will have one doubt. Sir, here each processor has arrived at different amount of time. It is well and good. Let's assume that the processor P3 and processor P4 has arrived at 0 units of time, exactly at same unit of time. Let's assume that. Then which processor? The processor P3 also arrived at 0 units of time. Processor P4 is also arrived at 0 units of time. Now which one will be shifted to the running state first? Then we will look at the processor ID. This is P3, this is P4. So this ID has less 1. So this processor P3 will be shifted to the running state first. Is it clear? Are you able to understand? Whenever the arrival time a tie is happened, then we will look at the processor ID. The ID which the processor which has the less ID will be served first. I hope with this explanation you have understood the first come first serve algorithm. If you still have any doubts, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.